All right, this is Unit 2, Lesson 14 for 6th grade, of course. In this lesson, we're going to continue practicing our double number lines and our tables to talk about those equivalent ratios. But in this lesson, we're also going to introduce a routine, an instructional routine called the information gap, where students are going to practice having an academic conversation where one student is trying to get information from the other, and the other student is trying to listen to that first student and decide whether she has the information that the other person is asking for. So, sounds confusing, but let's get started. All right, this is a nice little way to get started with our problem, our lesson for the day. It says, what do you want to know? So here's a problem. A red car and a blue car enter the highway at the same time. They travel at constant speeds. How far apart are they after 4 hours? So our job is to just make a list of what are all the things we might need to know in order to solve the problem. Parents and teachers, there's no answer key on this problem in this moment because it kind of depends on what kind of problem the students have in their brain. What kind of schema are they bringing to this story? So just collect your list and discuss it. So now we're going to introduce that information gap that I kind of referred to at the beginning of the video. And the idea is it's information gap. I'm going to put data card and problem card down here for problem card 2. Let's focus on number 1. All right, so you're going to get your students into pairs. So your whole class is going to be in pairs. Now, in their teams of 2, you have one kid is going to be given the problem card, and the other student is going to be given the data card. And then these 2 students are going to have an academic conversation where the student who is working on the problem is going to ask the data kid questions. The data kid is going to provide the information to the problem kid so that the problem kid eventually has enough information to solve the problem. They're not going to show each other their cards. That would remove the need to have an academic conversation. So the problem student is going to read her card, and she wants to use all the milk and the cocoa. Okay, how much milk should Jada use? And so this problem student needs to read through the information and ask the data kid some questions. So the data kid might start the conversation by saying, what information do you need to know? And so the problem kid might say, I need to know how much cocoa is in the recipe. And the data kid would say, well, why do you need to know that? And the problem kid would say, well, because I need to know how much milk and how much cocoa is in the recipe. It's because I need to know how much they use. And the data kid would say, well, I can tell you that Jada needs 2 tablespoons of cocoa powder. And then the problem kid might write that down because this is not a mental problem. So the problem kid will write down that piece of information. And then the data kid will say, what else do you need to know? And the problem kid will say, well, I need to know, ... And they continue back and forth, asking questions and providing information and going back and forth until eventually the problem kid says, I think I have enough information to answer the question. And then the 2 of them go sit down. They go sit down. And then and then the problem kid is going to do most of the solving, is going to take the lead in solving the problem. And the data kid is kind of quality control. Let the problem kid take the lead, but together they're going to solve this mystery together. But it's the problem kid who's taking the lead. The data kid is doing quality control. After a classroom conversation, everybody's happy. We've discussed this situation ad nauseum. You put that away, and now you have, well, where are we? There we are. Where are we? Golly, I'm all over the place. There we go. And then we switch roles. So the kid that used to be the problem kid is now the data kid. And the kid that used to be the data kid is now the problem kid. And we have another conversation. We have a conversation, but this time, this child is the problem child talking to the data child. And they have a second academic conversation trying to solve this new problem. So that is how the information gap is conducted. Now we have a more typical problem. We're comparing reading rates, and we've got 3 students. We've got Lynn, who read 54 pages in 3 days. We've got Diego, who read 100 pages in 4 days. And then we've got Elena, who read 160 pages in 5 days. And the idea is, if they each continue to read at that same rate, who is going to finish their book first, who's going to finish it second, and then finally, who's going to finish it third. So let's get that little piece out of the way, and let's make a table. We're going to make 3 tables. We're going to make a table for Lynn, we're going to make a table for Diego, and we're going to make a table for Elena. So Lynn, Diego, and Elena. All right, so let's read, let's do pages and days. Pages and days, pages and days. And so Lynn, we see, Lynn read 54 pages in 3 days. Diego read 100 pages in 4 days, and Elena read 160 pages in 5 days. Now our job is to figure out how long is it going to take each of these kids to read their book. So that's going to be my bottom row of my table. So now we see that Lynn is reading a 270-page book. 270-page book. We see that Diego is reading a 320-page book, and we see that Elena is reading a 480-page book. And we're supposed to figure out who's going to finish their book first, who's going to read it second, finish it second, and who's going to finish it third. Okay, so we have to think about how are we going to turn, in this case, 54 into 270. So this 3 is really going to be a clue for me. So let's see. If I divide by 3, if I divide by 2, I get 27, don't I? So if I times by a half, so that's my divide by 2, remember? And I need to zoom in here. So I'm going to times by a half, multiply by a half. And then I'm going to zoom back out here. There we go. So if I'm going to multiply by a half, that gives me 27, which means I'm going to multiply by a half, which means I get a day and a half. So I did that because I can see an easy relationship from 27 to 270. All I have to do is multiply by 10. Now that I've multiplied that by 10, I'm going to multiply this by 10. And a day and a half multiplied by 10 gives me 15 days. So it's going to take Lynn 15 days to finish her book. So now let's kind of do that same process for Diego. So for Diego, let's say we're going to divide by, gee whiz, what do I divide by? Let's divide by 5. So I'm going to multiply by a fifth. So I'm going to multiply by a fifth. and that gives me 20 pages in 4/5 of a day. And then I can multiply, oh my goodness, that's pretty straightforward. I can multiply that by 21, 16. 16, so I can multiply by 16, that gives me 320, which means I'm going to multiply this by 16. So 4/5 happens to be 0.8, right? So 4/5 multiplying by 0.8, 4/5 is 0.8. And then I'm going to multiply that 0.8 by 16, and that gives me 12.8. So it's going to take Diego 12.8 days to read his 320-page book. And now we're ready for our last person, Elena. So Elena, oh, this one's pretty straightforward. I could just multiply by 3. 160 times 3 gives me 480. So 5 times 3 gives me 15. So I can see, let's do it in yellow. It's going to take Lynn 15 days. It's going to take Diego, Diego 12.8 days, and it's going to take Elena 15 days. And that is how we know, oh wait, why is this? Yeah, and that's how we know who's going to finish first, second, and third. It looks like we have a tie for second place, actually, don't we? So just wrapping up this lesson, it's really a beautiful lesson. The idea is, in order to answer questions, we generally need at least some sort of unit or some sort of rate that tells us, in this case, we need 5 cups of cranberry juice for every 2 cups of soda water. So there's our rate that we need. And then that other piece of information we need is kind of like, what is our goal? What are we trying to figure out? And then we use our table manipulation, which is really just a bunch of equivalent ratios, to figure out that missing value. Beautiful, beautiful stuff here. So now it's time to just practice and keep working on it. So it says a chef is making pickles, and he needs 15 gallons of vinegar. The store sells 2 gallons of vinegar for $3 and allows customers to buy any amount. So decide whether each of the following ratios correctly represent that given price. So we have gallons and we have price, right? So let's put that into a table. So let's do gallons and price. And we're given that initial information, which is 2 gallons. 2 gallons is $3. So 2 gallons is $3. So then, is this correct? No, this is not correct, because 4 gallons would really equal $6. So that's no good. How about 1 gallon? What would 1 gallon be? Well, we know that divide by 2 or times by a half, divide by 2 gives us 1. So divide by 2, $3 divide by 2 is $1.50. So is that correct? This one is correct. Yes. How about 30 gallons for $45? Well, if we have 30 gallons right there, so I need to multiply by 30, which means I'm going to multiply this by 30. And 30 times $1.50 is indeed $45. So we're good. So that one, this one is a yes. Yay. How about $2 for 30 gallons? What? No, because we already did it right here. 30 gallons, that's got to be a no, because we already know that 30 gallons is $45. And the last one, $1 for 2/3 of a gallon. So $1. So what is that going to look like? Well, that means we're going to put 1 right here. So how do we go from $3 to $1? We're going to multiply by 1/3. Remember, that's the same thing as divide by 3. So what are we going to do with our 2? We are going to multiply by a third, and 2 times a third gives us 2/3. So this last one right here is a yes. That works, because we see $1 for 2/3 of a gallon, and that's exactly what we have here, $1 for 2/3 of a gallon. All right, so we have a caterer needs to buy 21 pounds of pasta, and we have a rate. Here's our rate. 8 pounds costs $12. So let's make a table. So we have pounds, and then we have money. And our big rate that we were given is 8 pounds costs $12. And our job is to figure out 21 pounds. How much will 21 pounds cost? So now we need to use some sort of recipe, some sort of multiple steps to turn in the 8 into the 21. So what I often do, because especially it even gives us a clue, would it be more helpful to write an equivalent ratio with 1 pound of pasta as one of your values? Or should we do $1 as one of our values? And since we're trying to get the pounds to be 21, it's really going to be nice if we get the pounds to equal 1. So how do you go from 8 to 1? You multiply by 1/8. So what are we going to do with our 12? We're going to multiply by 1/8. So 12 times 1/8, that gives us 12, 12/8. Oh, my pen is having issues. 12/8. So now we want to turn that 1 into a 21. How do we do that? We multiply by 21. So what are we going to do over here? We're just going to multiply by 21. 21. So now we have to do 12/8 times 21. So we're going to do a little bit of fancy schmancy math with our calculator, because we don't need to do this in our head. So we're going to multiply 12 times 21, and 12 times 21 gives us 252, and 8 times 1 is 8, and then we use division. 252 divided by that 8, that gives us 31.5. So we know our amount is going to be $31.50. Nice. So we have Lynn, good old Lynn again. She's reading a 47-page book, and she reads, and here's the key. She reads the first 20 pages in 35 minutes. So there's our table. That's the ratio table that we're going to do. And let's do it right here. So she read pages in minutes. And she read 20 pages in 35 minutes. And we want to know, how long is it going to take her to read a 47-page book? Because it says, how long will she be able to complete this book, right? How long will it take? So we need to take that 20 and somehow turn it into a 47. Doesn't matter how, but I'll tell you, since 47 is prime, we're going to have to turn this 20 into a 1. So let's do that. So we're going to multiply by 1/20. That gives us 1 page, which means we're going to multiply by 1/20, which gives us 35/20. There you go. And then we're going to do 1 times 47 to give us our 47 pages. So we're going to do 35/20 times 47. So let's do that. 35/20 times 47. So that is a gross problem. 35/20 times 47 over 1. So we're going to use our calculator, and we're going to do 35 times 47. That gives us 1,645 over, and then 20 times 1 is 20. Then we're going to use division, divide those two, and we get 82 and a quarter. So now we can go back. So how many minutes is it going to take? It's going to take 82 and a quarter. So does she have enough time to read this book in under an hour? Nope. In fact, she's definitely over an hour because we see that it's going to take her 82 minutes. Just more of the same. We got Diego, he's typing. We want to know how long will it take him to type 385 words. So let's do it. So we're going to make a table. We got words in minutes, and we've got 140 words in 4 minutes. And we want to know how long will it take him to reach 385 words. And then we also want to know how long or how many words can he do in 15 minutes. So we're going to answer a couple of questions with this table. So let's do it. So I want to figure out 385 words. So I want to turn that 140 into 385. So first thing I'm going to do is I'm going to turn it into a unit rate. I'm going to multiply by 1/140th, which is going to give me 1. Which means I'm going to divide by 140 or multiply by 1/140th. And that's going to give me 4 over 140. And then what am I going to do right here? I'm going to multiply by 385. So what am I going to do here? I'm going to multiply by 385. And that's going to give me the number of minutes for him to type 385 words. So let's do that. We're going to scooch over, and we're going to do that multiplication, that 4 over 140, right here, times 385, times 385 over 1. So let's do it. So I'm going to bust out my calculator. 4 times 385, that gives me 1540 over 140. Now I'm going to divide those two numbers, 1,540 divided by 140. That gives me nice, tidy 11. That wasn't so bad. So it's going to take him 11 minutes to type 385 words. So now we want to know, how about 15 minutes? How many words in 15 minutes? So that means I need to get the minutes to be 15. Well, here's a nice little cheat. In 4 minutes, he does this many words. In 11 minutes, he does this many words. So if we add 4 plus 11, we get 15. So what are we going to do over here? We're going to add 140 plus 385. When you add those together, you get 525 words in 11 minutes. So there's our first answer. Here is our second. A little bit of review this time. A train, so there's our where it's coming from, right? There's our little review. A train is traveling. That travels 30 miles in a third, is going faster than a train that's going this speed. How do we know? Well, we could take that 30 miles in a third, and we can say 30 miles in a third. So there's our 1/3, and it's traveling 30 miles, which means in another third, it would travel another 30 miles. In another third, it's going to travel another 30 miles. So in 1 hour, it's going to travel 90 miles. using that same logic, we can do the other train. It says it travels 20 miles in a half hour. So in my 1/2 hour, it travels 20 miles. So in the other half, it travels another 20. So in 1 hour, it travels 40 miles. So it's not even close. That first train is driving way faster because it could go way further in its hour than this train can go in its hour. Last problem is another review. We're supposed to find the surface area of this polyhedron that can be assembled by making this net, right? So basically, we need to find the area of each of these 5 faces, 2 triangles, 3 rectangles. What's the area of this rectangle? That's pretty straightforward. That is 40. How did I get 40? Well, let's do it in black. How did I get 40? Because I did 10 times 4. What about this rectangle? Well, that's also 10 times 4, so that's also 40. And then what about this rectangle right here? Well, this rectangle looks like it's got a width of 12 and a height of 4, so this rectangle has an area of 48. Looks like these two triangles are equivalent, are the same, are congruent. So let's find the area of this triangle here. It's got a base of 12, it's got a height of 8, and so we have to remember that the formula for the area of a triangle is 1/2 times the base times the height. So when we take the base, which is 12, the height, which is 8, and then times it by 1/2. So 12 times 8 is 96. Cut that in half is 48. So this triangle is 48. This triangle is 48. And remember, we should be calling them square inches. Now our job is to add all of these values, and that is going to be our answer. And actually, that isn't all that hard. Think about our 40s. 40, 1, 2, 3, 4, 5. So we have 5 times 40, that's 200, plus 24. So it's the area is 224 square inches. All right, so that wraps up grade 6, unit 2, lesson 14. Students are kind of continuing connecting those double number lines with the equivalent ratios, tables. They're really also learning that new routine called the information gap. If you have any questions, email me. My email address is down in the comments below.